My name is Fernando.
Hi, my name is Jaden. Hi, my name is Luis.
Together,
We are.
Hi, my name is Luis. I'm going to be y'all's main reporter for today. The topic me and my team are going to be talking about today is thermochemistry. I will now turn it over to Jaden to talk to you guys about an endothermic process through the ice cube.
An endothermic process absorbs heat from its surroundings. In case of ice melting, heat is drawn from the environment to convert solid ice into liquid water. This absorption of heat results in a cooling effect on the surroundings. Now I'm going to turn it over to my partner Fernando, where he's going to talk more about endothermic reactions in an ice cube.
Hi, my name is Fernando. I'm going to be talking to you guys about an exothermic reaction in an ice cube. And as you can see, the once melted ice is now an ice cube due to the energy, the heat being extracted from the water, making it turn back into ice again. I will now be passing it back to Luis for more coverage about thermochemistry.
Our next topic is system versus surroundings. System, the part of the universe that is being studied or observed. It could be a chemical reaction, a gas in a container, a living cell, etc. Surroundings, everything outside the system can be interactive. Exchange energy or matter. For example, if you're studying boiling water in a pot, the system might be the water, and the surroundings would be the pot, stove, air, and everything else around it. And now I'm passing it to Jaden. He's going to be talking about graphing potential energy versus time.
Graphing potential energy versus time means plotting how an object potential energy changes as time progresses. Key points like y-axis potential energy and x-axis is time. The shape of a graph shows how energy increases, decreases, or stays consistent over time. Pass it to Fernando to talk to you guys more about equation Q equals mc delta T.
The equation Q equals mc delta T is an equation used for specific heat, with Q being heat measured in joules or calories, M as being mass being measured in grams, C being specific heat capacity measured in joules over grams or calories over grams, and delta T measured in degrees Celsius. Don't forget, in order to find delta T, you have to subtract your final T from your initial T in order to get delta T. I'm now going to be passing it back to Luis to talk to you guys more about enthalpy.
Enthalpy is a thermodynamic property of a system that reflects its total heat content. It combines the internal energy of the system with the product of its pressure and volume. Enthalpy is particularly useful for analyzing heat changes in processes occurring at constant pressure as the heat exchange equals a change in enthalpy. And now I'll pass it on to Jaden talking about calorimetry.
Calorimetry is the process of measuring heat flow during a physical or chemical change. Now I'm going to pass it to Fernando about another equation.
Going back to enthalpy, delta H is always your change in heat. In order to get delta H, always remember that you have to subtract the product side from your reactant side to get your delta H. Remember that delta H is always not positive. It could also be negative. So if your final answer for delta H in a problem is positive, just know it is an endothermic reaction. Whereas if your delta H is negative, it would be an exothermic reaction.